Yes, children, today we're going to learn what is midpoint theorem. First, let us come to the statement. What is the statement of midpoint theorem? The line segment joining the midpoint of two sides. Line segment joining midpoint of two sides of a triangle is parallel to the third side and is equal to half of it. It means that there is a triangle and in the triangle we have the midpoint of two sides. These are the two sides. Let the name of triangle be ABC. AB and AC have the midpoint E and F. This is the statement. It is given in triangle ABC, E and F are midpoints of side AB and AC. Now what we have to prove? We have to prove the line joining these two midpoints is parallel to the third side and is equal to half of it. It means EF is parallel to BC and EF is equal to half of BC. This we have to prove. So for proving it, we're going to in the figure of triangle we are observing when the line EF is dividing the triangle into two parts. Upper part we have the smaller triangle, at the base we have trapezium. First of all, by construction we have to change this trapezium into a parallelogram. What we will do, we are going to draw a line from C parallel to and equal to BE. Let it be CL and produce EF to L. So EBCL. By this construction we'll get as a parallelogram. So what the construction we're going to draw CL parallel to BE and equal to BE, parallel to BE and equal to BE, and produce EF to L. Now come to the proof. What we have over here, in quadrilateral EBCL, by construction we have BE parallel to CL and BE equal to CL. So we have learned a theorem that if in a quadrilateral one pair of opposite side is equal and parallel, then it is a parallelogram. Since in quadrilateral BE is parallel to CL and BE is equal to CL, therefore EBCL is a parallelogram. And if this is a parallelogram, then the other side of it is also equal and parallel to each other. This implies that EL is parallel to BC and EL is equal to BC. Now in place of EL we have to get EF parallel to BC. If a line is parallel to another line, then its part will also be parallel to the line. EF is the part of EL, FL is the part of EL. If EL is parallel to BC, we can say EF is also parallel to BC or FL is also parallel to BC. So what is required? EF. So we are going to write EF parallel to BC. So in place of EL, we can write EF parallel to BC. So first part of the theorem we get. Now for the second part, we have to prove, for proving second part, we have to take the two triangle and we have to prove EF equal to FL. So that in place of EL, we get EF. Now come to the two triangle. Now in triangle AEF and triangle CLF, we have to prove these two triangles as congruent. So for congruency, what we have to do, here we can easily observe these two angles are equal. Why? Because they are vertically opposite. Angle 1 is equal to angle 2. Also, since F is the midpoint, so we can say AF is equal to FC. Now by construction we have written BE parallel to CL. If BE is parallel to CL, then this complete line BA is also parallel to CL. And if these two lines are parallel, this is transversal, then we can say these two angles which are forming alternate interior angle are also equal. So angle 3 is equal to angle 4. So by angle side angle we can say both the triangles are congruent, and if both the triangles are congruent, then EF is equal to FL, which is required, we'll get. So in triangle AEF and CLF, what we have, angle 1 equal to angle 2, vertically opposite angles. AF is equal to FC. Why? Since F is midpoint of AC, and angle 3 is equal to angle 4, alternate interior angles. So therefore we can say triangle AEF is congruent to triangle CLF by angle side angle congruency. By angle side angle congruency. And if the two triangles are congruent, then we will say EF is equal to FL. EF is equal to FL. Now come to the diagram. EF is equal to FL. If EF is equal to FL, then we can say EF is half of EL, or FL is half of EL, because both of them are equal. So this implies that EF is equal to half of EL. Now we have EL is equal to BC. Since EL is equal to BC, let it be equation number first. From equation first, in place of EL, what we can write? EF is equal to half of EL. So this implies that we can multiply, we can take 2 to the other side. 2EF equal to EL. We can write EL is equal to twice of EF. So in place of this we can write twice of EF equal to BC. Remove to the another side, we'll get EF is equal to half of BC, which is the required thing. So first we have proved EF parallel to BC. Now EF is equal to half of BC, which we have to prove, and we get EF is equal to half of BC. So this way we can prove the midpoint theorem. Thank you.